All right. All right, so I guess I'm final presenter. Thank you all for hanging in there. I have 15 slides for you, and then we are all free. So for those of you who don't know me, my name is Mark. I'm a software developer at UCLA on the software dev team under Joshua, and part of the services sub-team. And we have implemented IIIF, the IIIF Authentication 1.0 specification. Our implementation is called auth, and I think the pronunciation is the same as its cultural reference. And if you think you got it, you should let Joshua know at happy hour, assuming he'll be there. So for the roadmap and the QR code is URL to the slides. It's on GitHub pages. So if anyone wants to grab that, I'll have it on the last slide as well. But yeah, so the roadmap for the presentation, I'll review some concepts and then outline the library's motivation for implementing IIIF authentication. And then I'll talk about our implementation, there's requirements, what the development process was like, deployment status, light evaluation, and some implementation details, and then maybe a little bit about auth 2.0. So first, I'd like to do an informal poll of the room. I'm curious who in attendance is familiar with IIIF, the International Image Interoperability Framework. Somewhat, seeing some hands. Okay, cool. Who besides UCLA employees are at an institution running IIIF software in production? Like you have an image server, maybe you've deployed some viewers. Cool. Okay. Is anyone running a IIIF authentication implementation in production? Or has anyone experimented with the specs? Has anyone read the spec or skimmed it? It's okay. It's a doozy. It looks like there's a lot of familiarity with IIIF. And so my high-level summary that I came up with a couple hours ago is it's API specifications for interoperable software to represent, deliver, and render digital artifacts on the web. So this is things like images, books, audio recordings. Hopefully one day we'll get to arbitrary RDF subgraphs, just putting that out there, trying to manifest that. And IIIF authentication adds interoperable access control on top of that. And it's sort of like, again, like very glossing over a lot of details, describes how a IIIF client or viewer and IIIF servers should coordinate secure, authorized transfer of description resources. So that's like, if you're familiar with the info.json document that an image server like Cantaloupe would return, that shows like what sizes a given image is available in, or what its available color profiles are. And IIIF auth adds on to that like information about its authentication services, and then coordinating that with the content resources that those description resources provide metadata for. And the reason why this is a solution for this is non-trivial is because IIIF viewers are implemented in JavaScript, and content resources are typically loaded by the browser like passively by elements like the image element or audio element. And so for secure implementations, cookies and like credentials credentials like stored in cookie storage are not typically available to JavaScript. So there's like browser security rules that require a specification to like define or describe patterns for implementing this. And so we implemented version 1.0. There is a version 2.0 out there, and they're like sort of similar. One is like 2.0 is a generalization of sorts. I'll talk about that a little bit later. And so our 1.0 authentication, or our 1.0 implementation, works, but it relies on some web browser behavior regarding third-party cookies that is being phased out by the major browser vendors, as well as not being abstract enough or generic enough for some use cases. So why does UCLA Library need access control for some of its content resources? So complicated answer is copyright, political stuff, money, etc. So foregoing that, a simpler answer is that we have identified lots of materials for which access must be conditioned upon membership in a particular user group. And we have, our implementation does not support all of these yet, but these are the ones that we have identified in our sort of planning phase for for the future. So we have library staffs, which includes site administrators of things like the library digital collections, non-library UCLA staff who collaborate with the library, UCLA students who may be enrolled in a particular course where they require access to otherwise restricted collections. And then we have campus network users, which includes users with access to the UCLA VPN and guests, members of the general public. And then we also have users of bespoke research websites like the Sinai Manuscripts Digital Library that have their own bespoke authentication system. And so we focus on 2 of these user groups for our initial version 1 implementation of IIIF auth. And these are kind of the simplest or most well-defined methods of determining user group membership. So we're not dealing with single sign-on, multi-factor authentication schemes directly. Yeah, these are good first candidates for initial implementation. And here's kind of what our development timeline looked like. In my estimation, we started development in earnest in summer of 2021. And then we actually got pretty close to the minimum viable product in fall of 2022. And we only really started running or things in production, running the implementation production this spring. And the reason for that is because there were some gaps in the implementation on both the client and the viewer side. So our digital library digital collection site uses Universal Viewer for our images. And because of what I mentioned before about major web browser vendors deciding to phase out like certain ways of supporting third-party cookies, the UV developers had tabled implementing IIIF authentication. And like, given the straw poll that we just did in the room, like sort of a lack of implementations available seem to arguably make this reasonable. But this is something that we requested of them, and they did deliver on this. So we really appreciate that from the UV team. And then also on the server side in Cantaloupe. So the IIIF auth 1.0 specification requires, it interacts with the image API in that the info.json response contains authentication service information. So Cantaloupe did lack that functionality. And due to like limited capacity of that development team, we had to implement this functionality ourselves, and we're able to do so because Cantaloupe is implemented in Java, and we're a Java shop, so it ended up working out. And yeah, by spring 23, we have published a handful of restricted materials for campus network users. In the future, we have identified, although tens of thousands of items that we want to publish as well, several of which belong to 1,000-item plus collections with many smaller collections as well. And although the bespoke research website use case is implemented for the Sinai manuscript digital library materials, the bespoke auth system remains in place. But that has been tested in development, and I have a high level of confidence that it will work once we begin that migration process. And then I wanted to provide just some evaluation using a totally non-scientific rating scheme, but just my subjective opinion on sort of where we're at. And so for the campus network users group, this feature, I would say, is pretty decently open source ready. So any institution who wants to use IIIF auth and who can use Cantaloupe version 5.0.5 can have degraded access for whichever images you choose. And that mechanism degrades images by a certain configurable size reduction ratio. So for example, you can configure Cantaloupe to reduce, to serve images like half-size images, for example, to users who are off your network, and then full-size images to users who are on your network. And auth is configurable with any IPv4 network specification. So the way you specify it is sitter block identifiers, which are comma separated. And the drawbacks, unfortunately, are that number one, doesn't support IPv6. I guess that's fairly minor, depending on your point of view. Our specification, yeah, we didn't have any problem with that ourselves. But going forward in the future, it's an important development. And then there's no way to have multiple like tiers or multiple reduction ratios conditioned upon which image is being viewed or being requested. So all images would be degraded by the same factor or scale factor. And then all or nothing access is not implemented. So if you wanted to say restrict access completely to users on the network and then say users off the network don't get to see anything, that's not currently implemented, but it can be. And then for the bespoke research website implementations, it's very specific to the Sinai Manuscripts digital library, and basically copies the implementation details underlying sort of the credential issuing and cookie encryption. So it's pretty brittle. Although I think that it's possible that it could have been implemented in a more generic way with auth 1.0. I haven't fully thought it through, but I was kind of thinking about it. I've been thinking about it this week. And regardless, I think that auth 2.0, at least with my current understanding, provides a way is more clear on how to implement this use case in general, so that you don't have to re-implement in your server-side implementation this over and over for every app. So as an example of content restricted to campus network users, here's a live example of a 33-page document on our digital library collections website. So I invite you to try accessing it both on and off UCLA network. So either on the VPN or if you're connected to the Wi-Fi in the library, you should be able to see, you should be able to get to have deep zoom access if you're on the network, and then you should observe that that's restricted when you're off the network. And then as an example of content restricted to bespoke research website users, this is the URL for the Sinai Manuscripts digital library, and this is the view that you get when you're not logged in. So yeah, access to these materials is still determined by that bespoke authentication mechanism. And then I just want to talk about some finer implementation details. Like I said, we are primarily a Java shop. For this project, we use Java 17, and our build system uses Maven. And the primary build artifact is a Docker image, which we have been deploying with the Kubernetes GitOps setup that Anthony presented on earlier. And we are using Vertex as our sort of library / application framework. And we have been using this on the services team pretty exclusively for the homegrown apps that we've developed. We have IIIF manifest server and other applications that we've developed with this framework. And essentially how I like to boil it down is that it provides asynchronous types for building performant event-driven JVM apps. It contains the Netty HTTP server, and instantiating that is just like a single method call. It has tools for OpenAPI, integrating OpenAPI into your application for request and response validation. It provides asynchronous clients for making database queries, HTTP requests, and more. And something that I think is core to getting the most out of Vertex is familiarity and use of the future type, which if you're familiar with the promise API and JavaScript or async await, that's kind of a similar paradigm. So API methods throughout the Vertex ecosystem return this type. And something that we do a lot with it in Hoth is performing a flat map operation on it. So this kind of is a functional programming paradigm, and it is sort of what allows abstraction over like concurrent programming paradigms. So use of this type was not always required in Vertex. For example, so in version 3 of Vertex, there are API methods which do things what I have as noted the old way at the bottom of the slide. So these methods that return void, but take a callback function essentially, which also returns void. So the problem with this is that all of the expressions using these methods evaluate to null. And so you kind of get into like null pointer exception pitfall city, and just like deeply nested callbacks oftentimes. So these are actually deprecated in version 4 of Vertex. So they're kind of pushing users towards the approach of using futures and doing flat map operations on functions that return futures. Although this pattern arguably takes some getting used to, because like a lot of, for example, before, I guess lambdas have been available in Java for a while, but before I was using them, I was like writing ES5 JavaScript that like passed around callback functions a lot. And so for some like this, there's a learning curve to this paradigm. And talking amongst the services team, we have come to an understanding that like these like long chains of flat map operations can be difficult to read. And so it does help to give names to intermediate results rather than like chaining them, five calls, to flat map or its alias compose in a row. So like, for example, this is kind of a simple example, but the fourth line in the top, I have assigned the result of db client.get connection to a variable get connection. And so doing things like this, breaking up the ultimate expression into like pieces helps to make this code more digestible. And if you want to get into this, I highly suggest practicing with the Java standard library types stream and optional. They sort of operate in a similar programming paradigm, or JavaScript async await and promises. Okay, this is the last code snippet, I promise. I just want to go over like some light I don't know, some detail. I won't say light, I'll say some details of the 2 use case implementations that we have. So for the campus network users, we are doing an IP address check using a radix tree data structure, which is in this third-party library that we're using called sitter4try. And the availability of this implementation specifically for sitter blocks like made it pretty easy to come up with a way to determine if an IP address belongs to a particular network. Although some research on the topic of radix trees seems to indicate that this is a pretty common use case for that data structure, applying it to network routing. So I'm hopeful that implementations in other languages are available, or at least somewhat doable to implement. But I haven't done research on that, so take that with a grain of salt. And then for the access cookie checking, essentially we duplicated the decryption algorithm used by the Sinai manuscripts digital library, and we also therefore duplicated the secret key. So this is not ideal from a do not repeat yourself perspective. And just from a security perspective, like the fewer places you have to put a key, probably the better. But this was, this was our first pass at it. And then thinking ahead to the 2.0 spec, which is now, instead of the authentication API, it's named the authorization flow API. And essentially, admittedly, my understanding of the 2.0 spec is still pretty fuzzy, but my initial sense is that it provides a more general, or enables the use of a more general data model and provides a higher level of abstraction for covering more use cases. So for example, the access cookie service in version 1.0 is now called the access service, and that reflects the fact that the HTTP cookie header is no longer the required authorizing aspect of a client. So auth 1.0 forces you to use a cookie for every kind of authorizing aspect. So even if you want to just authorize using IP address, the spec wants you to represent that with a cookie somehow. So this will make implementing, in my estimation, implementing 2.0, this part of implementing 2.0 will be simpler. So no more unnecessary cookies for IP address-based authentication. And then the second generalization is that it's not just image resources anymore that can be auth. It's any IIIF resource type, content resource type. So in auth 1.0, the info.json is specified to be the carrier of the authentication services, but now it is not. It can be on the info.json, or actually in the case of images, it must be on the info.json still, but now it can be located on audio, video resources as well. And then instead of the services specified being a singleton object, they are now arrays. So that just opens up multitude of possibilities for one-to-many relationships. Although I saw somewhere that this is likely to be something that's not used very frequently, but I haven't thought too deeply about it. So it's interesting, I think. And then I did do some brainstorming of what like database schema for supporting 2.0 might look like in Hoth, and for like what transformations or like generalizations or parameterizations of the 1.0 classes would be required to like support 2.0. But I think I realized I have a lot of questions still about the auth 2.0 spec, and it's a lot more general. So it's harder to, I think, well, it's a lot more general, and there's an additional service called the probe service that is a lot more general than the, I guess, info.json service. So yeah, I don't think I'll say too much on that. I was going to say a lot more, but cold that, I think. And yeah, feel free to reach out to me. I feel pretty comfortable with my understanding of auth 1.0. Like I said, still getting up to speed on auth 2.0. You can email me. I'm on a couple of different Slack organizations. I'm also on the IIIF Slack. And that QR code is also links to the slides URL again, if anyone wants to capture that. But the last thing I want to do is actually talk about this slide preparation tool that I use, which I really like. It's called Remark.js. And if you like LaTeX, or if you ever use LaTeX and enjoy like procedural generation of documents, I think you'd like it. So yeah, if that sounds interesting to you, I recommend checking it out. So it has this built-in like presentation view that essentially renders metadata in your you write your slideshow in Markdown, and then you write the content of the slides in one section, and then you write the speaker notes also in Markdown in another section. And yeah, all of this is customizable with CSS. Like if I wanted to, I could bump the size of these speaker notes up if by like using CSS. So yeah, I think it's really cool. That's all.
All right, thank you. Question. Question. Mark.